Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Here we're going to talk about the problem of the day 19. In triangle ABC, AB represents for the length of the opposite edge of angle A, angle B respectively. Knowing that A times tangent A plus B times tangent B equals 2, A plus B times tangent half of A plus angle B. And we want to prove that A equals to B. So for this problem, there's no much technique to do. We just need to calculate for this equation here, the A tangent A, which can be rewritten as A sine A to cosine A, plus B sine B to cosine B equals to A plus B sine A plus B to 2 cosine A plus B to 2, right? And we can just move the right side of the equation to the left side, and we have A times, and we can rewrite these terms as cosine A plus B to 2 sine A times cosine A plus B to 2, right? And because here is positive sign, so shift it to the left side of the equation would be the negative sign. We have negative, and we would have cosine A here, right? Cosine A times sine A plus B divided by 2. That's for the term with the product of A, and we have B here as well, which is cosine B, cosine A plus B divided by 2. And on the denominator, it is sine B cosine A plus B by 2 minus cosine B sine A plus B by 2 equals to 0. That's the equation, right? We just reform it. We can still keep reforming it. We get here A times cosine A plus B to 2. So we know for here we have sine A cosine, let's consider it as beta, which is sine A cosine beta minus cosine A sine beta. So we can write it as sine A minus beta, right? Beta is this one. And similar for here, we have B times cosine B cosine A plus B by 2. And on the denominator, we have sine B minus A plus B by 2. This one equals to 0, right? And we can get A times this one. It is sine A minus B by 2. 2 cosine A plus B by 2 plus B times this one. This one is sine B minus A by 2, right? And divided by cosine B cosine A plus B by 2 equals to 0, right? So this can be rewritten as A times cosine A cosine B cosine A plus B by 2. And here we have sine A minus B by 2 times, so this one we times cosine B, right? And plus for this one we have B, here we can just use minus B times, this one can be rewritten as sine A minus B by 2 and times cosine A divided by cosine A cosine B cosine A plus B by 2 equals to 0, right? And we already know that A equals to 2R sine A and B equals to 2R sine B. So we put these two into the equation, then we have 2r sine a minus b divided by 2 times sine a cosine b minus cosine a sine b 2 cosine a cosine b cosine a plus b by 2 equals to 0, right? Which means either sine a minus b by 2 equals to 0, or for this one, we have sine a minus b, right, equals to 0. Either this one or this one equals to 0. Then we know that in triangle ABC, right? So that means the angle A minus angle B should be less than pi, right? Larger than minus pi. Then the only valid solution that sine angle A minus B equals to 0, or this one equals to 0, would be A equals to B, right? Angle A equals to angle B, which means A equals to B. Okay, so this is a problem from Fujian Fuzhou math computation in 1978. Basically, if you know about the relationship of the sine, cosine, and the tangent, and you know about the that sine alpha plus minus beta, you know how to extend this to the production of sine and cosine terms, then this problem should be not that difficult. Okay, I hope you like this video. See you in next one. By the way, I didn't talk about the problems at day 18 because it's too easy. It's just two triangles that are incongruent, so we will just skip that one. Okay, see you in next one. Thank you.